All right, what's up, everybody? In 3.2, we're going to be solving systems algebraically. So today we're going to focus on substitution and elimination and how you could use it in a word problem. So to start, we'll look at substitution. Here we have the equation 3x plus 4y equals 12 and 2x plus y equals 10. So here we have two equations because we have two unknowns, x and y. And we could use substitution to solve this. If you want to use substitution, what you first have to do is isolate a variable or get a variable by itself. Here, I see that y in my second equation has no coefficient with it, so that's going to be the easiest to isolate. All I'm going to have to do here is subtract 2x on both sides. That cancels. And now I have the equation y equals 10 minus 2x. It's still the same equation, I just kind of manipulated stuff around a little bit. Now that y is by itself, I can sub that variable in the other equation, so I can get myself down to a one variable equation. What I'm going to do here is I'm going to take this whole equation for y and plug it into that first equation. So now I'm left with 3x plus 4 times 10 minus 2x equals 12. And even though this equation looks kind of uglier and it's a little bit longer, notice how I only have one variable x, so I can in fact solve for x and get a number value for that. I'm going to distribute, combine like terms, divide everything by 5, and I get x equals 5.6. Now that I've solved for x, I'm going to be able to use that to solve for y. I can plug it into either equation. I'm going to plug it into the bottom one. 2 times instead of x, I have 5.6 plus y equals 10. Get the y by itself, and I have y equals negative 1.2. And if I graphed these equations by putting them in slope-intercept form, they would intersect at the coordinate 5.6 comma negative 1.2. The other method that I can use to solve is elimination. Personally, I like elimination better. I think it's kind of easier to use, but to each his own. In elimination, we have the equations 2x plus 7y equals 4 and 3x plus 5y equals negative 5. Now, personally, if I saw two equations like this, I don't see any variable that could easily be by itself. So that's where I would really start to think about elimination here. What I'm going to need to do is match up a term by its coefficients. Right now, nothing's really matching up or looks similar by having the same numbers with it, but I can manipulate both equations to get it to be like that. So what I'm going to do is I'm going to get the x's to match up. You could do the y's either, it doesn't matter. I'm going to multiply the top equation by 3 and the bottom equation by 2. And now what's going to happen when I multiply every term on that top by 3 and that bottom by 2, now I have 6x plus 21y equals 12 and 6x plus 10y equals negative 10. Now my x's match up and I'm easily going to be able to eliminate them entirely from the equation. Then I'll have my own one variable equation to solve. What's important to note here of how I can eliminate is if there's opposite signs, so if those x's were opposite signs, I would add the equations together, and if they're the same sign, I'm going to subtract them. Here, since I have positive 6x and positive 6x, they have the same sign, so I'm going to subtract these equations. When I do that, 6x minus 6x will be 0, so they completely eliminate. 21y minus 10y will be 11y, and 12 minus negative 10 will give me 22. Now I have a one variable equation again and I can solve for y entirely. I'm going to divide both sides by 11 and I get y equals 2. Now, same as that last problem, I'm going to plug y in and solve for x. It doesn't matter what equation I plug it into. I'm going to plug it into the top equation again. And then when I solve, I get that x equals negative 5. So again, if I wanted to get both of those equations into slope-intercept form and graph them, they would intersect at the point negative 5, 2. Finally, what we're going to look at is some word problems, and what we're going to focus on is how to set up these equations. From there, you can decide if you want to use substitution or elimination. Both of those are tools that you can use to solve. So in this situation, you are the manager of Fiona's at Willoughby's. You purchase your decaf and regular coffee from a local supplier at the West Side Market. Decaf costs $6.50 per pound and regular costs $8.75 per pound. Last week, you ordered 41 total pounds of coffee beans, and your purchase came out to be $327.25. Using that information, you want to figure out how many pounds of each type of coffee did you purchase. So when you have these kinds of equations, they're always going to be set up in the same way. I want to make two equations because I have two unknowns. I'm going to make one equation that deals with cost and the other dealing with quantity. And my unknowns, just to specify, I don't know pounds of decaf and pounds of regular, and I'm going to call that D and R. When I want to make my cost equation, I'm going to highlight or look at anything in that text that has anything to do with the cost of this. So I see decaf costs $6.50 per pound, regular costs $8.75 per pound, and I total spent $327.25. I'm going to use those to set up an equation. I'm going to write 6.5D plus 8.75R equals my total of 327.25. And what's important to note here again is since I have two unknowns, I need to make a second equation to be able to solve. And all I really have to do for that second equation in quantity is make an easy, simple equation. I ordered 41 total pounds of coffee. I don't know how many of each type that I bought, but I know that decaf plus regular equals 41. So now I have my two equations, and from this step, you can kind of decide, do you want to use substitution or do you want to use elimination? I personally, again, really like elimination, so I'm going to show you how to do that in this video. We'll go over substitution in class. So if I use elimination, I need to get a variable to match up. Here, since all of my coefficients in that quantity equation are 1, I could just multiply one equation to get it to match up with the top one. So I'm going to multiply the bottom equation by 6.5. That's going to get the D to match up. When I multiply everything by 6.5, this equation turns into 6.5D plus 6.5R equals 266.5. From here, my D's match up. They have the same sign. So again, I'm going to subtract. They eliminate out of the equation entirely. And then I kind of combine everything else. 8.75 minus 6.5. Give me 2.25R equals, on the other side, 60.75. Now I have an easy one variable equation. I'm going to divide. And then I get that R equals 27. So using that, I figured out I ordered 27 pounds of regular coffee beans. And what I'm going to do is plug it back in to solve for D. Personally, I would use the easier equation, which was my quantity equation. So I know that D plus R equals 41. Here, D plus 27 equals 41. From there, I could figure out that I purchased 14 pounds of decaf coffee beans.